problematic issue if we want to cross-fertilize and learn from each other, because we should be using the same language at the end of the day, so so that meaningful exchange can happen. And this is also, it has been a very big challenge for the project, but it will be an even bigger challenge for the future activities in this area. Next slide, please. This is what we have been working on with. As I said, the project itself is coming to its end, and there are still 3 tasks to be done. It's task 5, 6, and 7. So cost benefit assessment or methodology or ideas how to go about it, some case studies, and then the final issue is the proposal for the way forward and what would be the follow-up of this project. On this slide, you will find a link to the project website. The website is set up by the leader of the consortia, and if you go there, you will be able to find channels to give feedback or ask questions, and you will already find task reports of task 0 until 4. So if you're interested, more information is available on the project website. Next slide, please. Then coming to FIEP activities or Fire Information Exchange Platform. As I mentioned, the things that we cannot regulate, it doesn't mean that Commission or the EU could not have activities or could not facilitate improvements in that area. And FIEP is one of the examples in the Commission specifically for the fire safety. It started in 2017, and as you can guess, I think the initiating event was the Grenfell accident, tragedy, where European Parliament became very active in the area and considered that there must be something that can be done also at the EU level, and this kind of initiated the FIEP activities. The main focus of the activities is on the building fires and specifically on domestic fires, and the areas that we are looking at broadly, let's say it's not cast in stone, but the main focus areas that the FIEP is putting its fingers is the common terminology and fire statistics. Now there was a separate project starting for that purpose in DG GROW, application of fire prevention principles. Of course, an interesting area, and now with all this energy efficiency things will be the new products that we will be installing in our buildings. Exchange on experience on fire accidents and investigation, for example, and then last but not least, the fire engineering or performance-based design in relation to fire safety. Next slide, please. This is a kind of a bit of a teaser about activities that we have had lately. There was a moment when there were basically no activities because we were under the COVID limbo. So the initial idea was to have physical meetings, but then it became clearer and clearer that this was not possible, and God knows when it will be possible again. But these are the webinars that we organized during this year. The activities of FIEP is supported by a technical secretariat, and we are now in the process of concluding a new contract for technical secretariat. I hope we will be able to do so maybe February or beginning of next year. But the activities will continue more or less in the similar way. So we are probably going to see more webinars. There is a possibility that we could start some kind of specific projects on specific topics if there is enough interest among the platform members and commitment to take that work on their responsibility. We have a electronic exchange platform, which is Circa BC, not very flexible one, but all the meeting information and documentation is there. And if you want to get, if you're not yet involved and you want to get involved, please drop me an email and let's figure out a way to find your account in the Circa BC so you will be informed of the activities. This was all that I wanted to present today. Thank you very much for your attention, and I'm of course available for any possible questions. Thank you.
Thank you, Heikki. We will take the questions at the end of the presentations if that's okay for you. But thanks for the interesting update from the Commission. I think information sharing and also data collection and the way we collect data is very important if you look at the way we understand incidents. Together with sharing best practices between the different key stakeholders in fire safety, it can help us to create a better and a more fire safe Europe going forward. So thanks for sharing the information. Before we go into the study of false alarms, it would be good to understand the impact from another key stakeholder, which are basically the alarm responders. As everybody knows, fire alarms can trigger a dispatch from the fire brigade. And with the increased amount of fire systems and the number of unnecessary alarms growing also, the dispatches can of course also increase. For alarms responders, this can be a serious challenge because they want to use their resources in the best possible way. And if you dispatch a few fire trucks to one part of the city, then they are not available in the other part of the city. Somebody who knows a lot about that is Michaël Bertels from the Netherlands National Association of Fire Services. And he would like to give you a view from the fire responder side. So, Michaël, I would like to invite you to take the floor.
Thank you, Paul. Martin Harvey mentioned something about the definition. What is a false alarm? What is a true alarm? This definition might not be the same from all perspectives. So you might need different definitions from different perspectives. That's exactly what I'm going to do this afternoon with you. We are organized in regions and we have a national association, and I'm project leader for this national association with regards to automatic alarm calls. Next slide, please. Well, first let's talk about fire propagation. So I might have an object on fire and the fire might propagate to the room. It might further propagate to the building and so on. And next slide, please. Just before the object is on fire, something somewhere was scorching. So there was something becoming too hot, which caused scorching, which is actually the phase before object on fire. And if I can have the next slide, please. The fire detection installation is actually designed to detect smoke from scorching. You might be familiar with a test fire where you put a few wooden blocks on an electric plate, turn on the electric plate, and the smoke from the scorching is supposed to trigger the fire alarm. That's the most commonly used standard fire size. Next slide, please. So scorching is considered a real or verified alarm from the perspective of the fire detection installation. Next slide, please. And I've noticed that you categorize false alarms into equipment failures, deceptive situations, and human errors. And if I can have the next slide, please. So, and one more slide, I'm just building up the tension, right. And I'm familiar with these categories, but I would like to add one more layer. And if I can have the next slide, please. I think I get the table, right, yeah. So especially in the case of deceptive alarms, I think there's a huge difference between smoking in a smoking lobby or smoking somewhere where I'm not allowed to smoke, or cooking in a kitchen and cooking in a place where I'm not allowed to cook. In case I am cooking in a kitchen or taking a shower in a shower, the person who designed the fire installation should have realized that there might have been some steam or a little bit of cigarette smoke. And he should have adjusted the design of the fire installation. So, I get a thumbs up there, great. So actually, it's a fault in design that has caused this particular deceptive alarm. On the other hand, if I'm smoking in a place where I'm not supposed to smoke, or I drive my scooter in a corridor where I'm not supposed to drive my scooter, I get a deceptive alarm call because caused by use. And the interesting thing between this distinction, in case of use, I must adjust the use. In case of design, I must adjust the design. So someone else is responsible for the appropriate action. Now, if I look at this, if I can have the next slide, please. If I look at the statistics in the Netherlands over the past 5 years in my own safety region, I noticed that about 50% of all false alarms are caused by use, and the other 50% are caused by design. And less than 5% are caused by a situation that is considered real in terms of the fire installation. And then I go to the next slide. I go back to my fire propagation, and one more slide, please. So I get less than 5% real verified, you might call them verified, fire alarms. And if I go to the next slide, and less than 0.5%, I get an object on fire. In case the object is on fire, there are installations present for the user to terminate the fire, to extinguish the fire. For example, the fire hose. There's a lot of fire codes who actually prescribe the presence of a fire hose, and the use of the point of prescribing a fire hose is that you expect from the user to put out the object. Otherwise, you shouldn't have put that fire hose there in the first place. And then even less cases, if I can have the next slide, please. It's a situation where the urgent dispatch of a fire truck is required. So the fire is so big, has been developed in such a stage that the user cannot tackle the fire anymore, and the fire service is urgently needed. Now, if I can go to the next slide. So remember, less than 5% verified real alarms that you would not call false, but a factor 100 less, 1% of these cases, the fire service is really needed. Now, if I can go to the next slide. So I introduce a new concept here, and when the object is on fire, you could say the fact that there's a fire has been confirmed. So confirmed has a distinguished different meaning than verified. Fire is confirmed. If an object is on fire, there's fire, you may call the fire service, and we're happy to help you, even though you might be able to do it yourself. But you know, the real fire, the verified alarm, I'm not really interested in those because it's just a few wooden blocks on a cooking plate or a toasty in the oven or something you forgot in the microwave. You can deal with it yourself. You do not need the fire service. So if I can go to the next slide, please. So verification of alarm is very useful for the user. If I can have the next slide, because it can help him eliminate false alarms caused by use and design, faults in use and design. However, and I come to my final slide, before calling the fire service, you need additional confirmation. You need confirmation that there really is a fire. So I need more than just verification, I need confirmation. And if the fire is confirmed, we will dispatch the right vehicles and help you immediately. And this is my last slide. Thank you.
Thank you, Michael, for the update. Michael, one question before we go ahead, because in our pre-conversation you mentioned we didn't talk about percentages, but we talked about numbers. And I have a number in my head. I don't know if you can confirm that on the 50,000 dispatches in the Netherlands, only 50 cases justified a truck roll. Is that how you translate the let's say, the percentages on your slides back to real truck rolls?
Yeah, that's right. We started this program about 7 years ago, and we started off with 50,000 automatic alarms, and we had the habit of immediately dispatching a vehicle to each call. Then we started applying pressure to the users to increase the quality of their fire detection equipment, which resulted in 50% reduction. So at some stage, we now only have 25,000 automatic alarms. And if you look at statistics, but that was your question. Out of those 25,000, about 5,000 are real in terms of fire detection. 500, there was some kind of damage, so some soot at the ceiling, on the ceiling, and about 50, the fire service was urgently needed. And I do not have enough statistics to tell you if those 50 times the fire service was needed to make a difference. So I think that's even less than that. Yeah, so that's to answer your question. And we have introduced a very important new philosophy in the Netherlands. We used to think that an automatic alarm was an urgent task. That's why we dispatched the vehicle right away. Now we realize that an automatic alarm from a normal fire system is not an urgent task for the fire service. So we take a few minutes, up to 5 minutes, to call the object to find out if they can please confirm that there's a fire. And this has resulted in a factor 10 less dispatches. But it's my ambition to further reduce this by another factor 10 or perhaps 100.
Thanks for the answer, Michael. I think this is also a good introduction going into, and thanks for sharing the information also on the numbers in the Netherlands. I think it's a good moment to go to the false alarm study and see what this is a follow-up from a study we did already a few years ago with a task group within the fire section from Euralarm. And Sebastian Festag, who is leading the task group, can tell you much more about that. So I would like to hand over to Sebastian.
Yes, thank you very much, Paul. Thank you, Michael. I think we have a lot of stuff to discuss. Yes, ladies and gentlemen, very welcome to this presentation. Thank you for your interest. I would like to give you an insight into the false alarm study. From the content, I would like to give you an introduction with some fundamentals. After that, I will talk with you about the method part, and then I will share some results with you. And after that, I come to a conclusion and to the outlook. You can see here on the slide the task group members. I have the lead of this task group, and you see here the advisory group from the different countries we have visited. Next slide, please. At the beginning, I would like to give you a first statement. If we discuss the topic of false alarms, it is a topic which we are dealing in the fire industry and the technology part. At first, I have to make a clear statement. False alarms are not only a topic of fire detection or something like this. False alarms are part of all information exchange and occur in the context of warning systems in different applications and environments with different technologies. If we take a look, for example, to cancer diagnosis, we will have false alarms. If we take a look to intrusion systems, we have false alarms. If we take a look to personal scanners at the airport, we have false alarms. If we take a look to and so on and so on. And of course, if we take a look to fire detection, we have also false alarms. And if we differentiate here, we can say, okay, let's take a look to false alarms in the context of fire detection and fire alarm systems. In detail, it is not the same if we talk about the fire detection fire alarm system and a smoke alarm, for example. That are two different things. And in this presentation, I would like to focus on fire detection, fire alarm systems. Okay, next, before I come to the next slide, I would say in the modern time, we are not talking about false alarms, we are talking about fake news in the context of politics and so on. So false alarms are everywhere. Okay, let's take a look. What are false alarms? And Michael have explained it very well. I think this picture will help us to understand. The first thing is on the left side. Okay, we have two possible situations. On the one hand, we have a fire or we have no fire. And now we come to a fire detection in the middle of this slide. We have a signal fire situation, a fire alarm. And now we have 4 possible situations. The first one is we have a fire alarm with a real fire condition, and the discovered situation said, okay, there's a fire condition. So we have a real fire alarm and we have indicators for this real fire alarm situation. Okay, that is a real alarm. The usual situation is that we have no fire condition signaled and not discovered. That is what happens everywhere when we have no real fire, of course. And then we have the possible situation that there is a fire alarm and the discovered fire situation could be changed over time, by the way, said, okay, there is no fire condition. Then we talk about a false alarm. More important are the points in the middle here where we don't give the signal or an alarm of a fire situation, but we have a fire. That is the worst case scenario. Okay, let's focus on the false alarms, and I will point out and make clear it is also a question of the perspective. The situation from the owner can change to the situation and perspective of the fire service, for example. But I will point it out on the next slide a little bit clearer. Okay, that are false alarms, and we are now focusing on false alarms. And as we have conducted our work, we have visited a lot of countries, and there were a very interesting discussion. In some cases, it is very clear what is in fire. In other cases, it is very clear that we have a fire alarm without any fire condition, or a fire intervention was not necessary. But there are also situations between that, and you will see it here on these pictures. Here's a recycle bin. Is it a fire or is it not? Question mark. This toast here in the middle of the figure, is it a fire or is it not? So you will see, okay, in not all cases this is very clear. Do you talk about a fire alarm or a false alarm? And maybe 2 different people have 2 different opinions. And one point more, in Sweden, at the fire service in Greater Gothenburg, we have met a colleague from the advisory group, Bert Paulusson, and he said, there's just one more option. There are happy alarms existing in Sweden. And I said, okay, sounds interesting. What is a happy alarm? And he said, a happy alarm is an alarm where a fire detector gives a fire alarm. And as the fire service comes out to the object, they have seen, there's no fire. But there is flooding or something like this with a lot of water, and the water steam has triggered the fire detector. And he said, it is not very often, but they have such conditions where they say, okay, they were happy for the alarm, but it was not a real fire alarm. Okay, next slide, please. So the distinction, one slide back, please. Okay, what is a false alarm? We have dealt with that topic, and I will show later that it is dealt very different in the different countries, but we have makes a statement, okay, false alarm. The definition, a false alarm is defined as a fire alarm when there are no conditions that justify a fire intervention. That is the definition. We have some notes. The alarm is not classified as a real fire alarm. A fire intervention is unjustified. And the second note was, in some countries, the term false fire alarm is used as unjustified, unwanted, and untimely alarm, or as a subcategory. For example, in Denmark, we are talking about false alarm as an intentional alarm and blind alarm as unintentional alarm, and so on and so on. I will show the details later. So the definition from us is to say, okay, a false alarm is defined as a fire alarm when there are no conditions that justify a fire intervention. Okay, next slide, please. It seems to be very simple. It is not really simple, and it is not simple when we go one layer deeper and say, okay, what are the reasons or subcategories of such false alarms? And this picture show it very well. We have 3 categories, Michael have pointed out in his presentation, where we have the equipment false alarms. They are in maximum 15%, of the cases, as we have seen, and I will show later. And here we have interruptions or technical failures from fire detectors or cables or something like this. A technical problem, a real technical problem. Then we have deceptive false alarms. There the technical systems are functioning properly, but fire-like phenomena triggered a fire alarm, for example, dust, vapor, and so on. And the third category is triggered by human activities with malicious and good intent. And you cannot clear subcategory here in the reality. For example, if you take a look to the construction work, it shows, okay, it is done by a human being, and they do not have protect the detector in construction work, and then we have dust and so on, triggered an alarm. What is it? Is it a deceptive alarm or is it not? So you cannot make it clear in all cases. More or less, these categories are working together and combined. So to make it easier for standards and so on, we have said, okay, let's take a look. Okay, we have the equipment false alarms or technical failures on the one hand. We have the deceptive false alarms where the systems are functioning properly, and we have the malicious and good intent. Okay, so far so good. Next slide, please. When we are dealing with false alarms, we are talking about absolute numbers and we are talking about ratios. One of our first steps was to make clear, okay, what are we talking about? If someone talk about a ratio of 60% or 90% or 99%, what is he talking about? And we have seen that in the different countries, they are working with different numbers, and we have clarified that point, that we have said, okay, you have to take a look to the number of false alarms, and then you have to calculate them on different bases. Here, for example, of 100,000 inhabitants, the number of fire interventions, the number of fire interventions in buildings, or let's go more deeper into our context, number of installations. It is very, very different if we take a look to FA3 or FA1. And the last point here was to take a look, okay, one ratio is, and that is, from my point of view, the best one at the moment, I will explain it, the number of false alarms due to fire detection fire alarm system. It's per year in one region. And you have the reference base to take a look to the number of all fire alarms due to fire detection fire alarm systems, the real and the false alarms. But in a lot of cases, they are not documented very well. That is the problem of this issue. And we have seen in Denmark, where they are dealing with FA5, they take the number of false alarms and related them to 1,000 fire detectors. That is the clearest information, but this is not documented in all other countries. I have not seen that point in Germany, Switzerland, and so on. So in the most cases, we could calculate the false alarm ratios on FA4. Next slide, please. Before I show you ratios and so on, I will point out 2 issues. The first one is, if we have a false alarm, what are the problems? What are the risks of false alarms? And in a lot of cases, we are talking about costs. How expensive is one false alarm, and so on and so on. Okay, yes, they produce costs. It is so. And by the way, it's not only the costs. We have raised some resources, for example, that we have an increased traffic risk for the fire services and all other participants in the traffic area. We have demotivation of fire services and so on due to false alarms. Yes. The major problem is, or important problem is, that we have a loss of acceptance to this technology. If you say, oh, okay, if a fire alarm from a fire detection system, it is a false alarm. That will not be good. And the last point is that we have a loss of effectiveness of the warning system, that the owner or the people in a building do not react as they should fast. That are the problems. By the way, next slide, please. We are focused on the problems. I will not make it nicer than it is, but there are also some positive moments. It is a side effect. It is a negative point, of course, but there are also some positive moments. I will point out here we have the advantage of action routes, experiences by, for example, the fire services. And I've met fire service officers. They have said, I have no problem with the false alarms. It's a question about ratio, of course, but in a lot of cases, my employees go out into the objects and see what's going on in their region. We have some optimizations of operational strategies and tactics on this point. We have dealing with stress reactions. We have the identification of weak points in the alerting process. We have some cases where we have seen that in a false alarm, some weak pointers could be pointed out without damages. Then we have the behavior in case of a fire affected of the persons. The persons learn to deal with those situations. The stress level will declining. It's not so good, but they learn how to do in such cases. Okay, next slide, please. So we go into the details. We have seen we have a lack of understanding of the existing false alarm values, of course, but it's more the quantitative part. And we have reliable details on the range of false alarms, difficulties, and their causes. And our aim was to discuss those things and to get a common understanding and to have a suitable basis to define and deploy effective countermeasures of false alarms. By the way, we have carried out this study, and the study is published as a book. Now we have the second edition. We have clarified some terminologies, and we have elaborated a fact sheet how to reduce false alarms. There are a lot of best practices, as we will see later. Next slide, please. What have we done? We have visited some countries. Next slide, please. Is there a technical interruption or another problem?
No, we hear you loud and clear, Sebastian. So
next slide, please.
The slide has gone to slide 46 in the meantime. So I don't know if you see the same.
I see slide 44.
So slide 45 is on at this moment. Sebastian.
The end of 2021 is just around the corner.
Okay. Now we are on 45. Thank you. Okay.
Thank you for your support and commitment for Europe to Euralarm.
Okay, we are on slide 45. Okay. So we see here the countries we have visited. We have visited Germany, Great Britain, England, Switzerland, Sweden, in Austria, Vorarlberg, and Denmark. And we have analyzed here the general procedure, how to collect data, how is the general procedure in the different countries. We have taken a look to the relevant standards, the used terminology on real and false alarms and subcategories and so on. the alarm transmission connection, some alarm criteria, statistics, facts, and trends. Some of them I will show you. And we have collected the best practices for the reduction of false alarms. Next slide, please. At first, if we are talking about false alarms, I have shown you the definition, but it is not so easy as it seems. If we take a look to the countries here, in Germany, you can see, okay, there we are talking about false alarms, technical defects, deceptive alarms, malicious and good intent. If we take a look to Switzerland, then they are talking about unwanted alarms. What in Germany is called the false alarm. And they are talking about the false alarm here in the cases where we have some other issues. And the malicious act here is similar, but the good intent is into the false alarms. And okay, you see, oh, it does not work together very well. Then we take a look to the TS 54-14. Then we say, okay, it is relatively similar to this approach. In Great Britain, it is similar too. If we take a look to Sweden, they have a very interesting approach. They have 25 sub criteria and do not build subcategories, but up to now they have changed that procedure. And then we have to take a look to Austria. They are talking about false alarms, okay, technical defect and deceptive alarms. Malicious is not named here. And if we take a look to Denmark, they are working different too. So we have seen, okay, just one issue, false alarm. And in different countries, everyone is dealing with other terminologies. And in the US, it is they are talking about unwanted alarms, and then we have some unjustified and so on. It's very confusing. But let's move on. Next slide, please. That is the terminology part. If we take a look to the causes, this slide will be very interesting. And Michael, I guess we have to take a look to your 50-50 approach. Let me show you. We have conducted a study in Germany where we have collected fire reports of building fires from 28 fire services, different fire services, with more than 5,000 fire alarms. But from this more than 5,000 alarms, we have just 1,200 real fire situations. And if we take a look to the false alarms and we classify them here, you see, okay, 3,796 false alarms overall alerting paths. And if we differentiate here to the subcategories, we see, okay, the main issue is the deceptive alarm and other unknown alarms from all building fire alarms. And here the false alarms. And if we now take a look to the transmission way, we can differ between the landline, the mobile phone, automatic fire detectors, manual call point, fire extinguishing systems. In some cases, you can combine fire extinguishing system with a direct fire alarm. And if we take a look, what happens here, we will focus on the fire detection system here with a false alarm ratio from around about 80%. We will ask later, is it high or not? And if we take a look here to this issue, we see that 44% of these false alarms are combined with deceptive alarms, where the systems are functioning properly. And deceptive alarms show that we have a planning and application issue. It's not only a question of a technical system, it's a question, how have you planned and so on. It's more an application issue, yeah, planning and application issue. Okay, let's move on. Next slide, please. We have to remember that point. I've said the perception is very different, and if we take a look to the numbers of false alarms in some different countries, cities, and so on, we have seen someone have said they have a problem, other have said no, we have no problem. One said I have 1,000 false alarms per year, I have no problem. The next one said I have 100 per year, I have a problem. and so on. And we said, okay, interesting. And the first point is to make one issue clear. You cannot talk about the false alarm problem in numbers, in absolutely numbers. They don't say anything. You need some ratios to clarify what you are talking about. And you see it here. It doesn't make sense to derive conclusions by the absolute number, as these are based on structural conditions. It cannot be used to measure whether the number is high or not. Next slide, please. We go deeper. If we now take a look to the false alarm ratios and the different countries, it's not a benchmark system. It is absolutely the statement and the key message. In the different countries, we found different quality and quantity of data, material, and statistics about false alarms from FDS. And these values show similarities, but they are not suitable for direct comparison because the situations, the data collection, the terminologies, and so on are so different that it makes no sense to compare them. But you get an understanding that if you are talking about FA4, again, is the number of false alarms in relation to the number of all alarms of a fire detection system. Here we have a ratio from around about 80% over all countries, around about 80%. Is that high? We will discuss it. Next slide, please. The first point is, or the next point is to take a look, okay, what happens over the time schedule in the last X years. And as we have taken a look to Switzerland, Austria, Vorarlberg, and Germany, we see if you take the number of false alarms per year and you take them into connection with the number of installations, the real fire alarms, which are identified, are linear. And the number of false alarms as ratio FA3, number of false alarms per installations, we see they are declining. There are some good trends to see. Okay, next slide, please. What are the reasons for these developments? And there are a lot of best practices we have collected in the different countries. To make a first statement, we have some product issues. We can take smoke detector or multi-sensor detectors. You can optimize the algorithms, use high-quality products, and so on. There are product issues. There are planning issues. Take suitable detectors or sensitivities in settings, measuring principles, for example, for the detector depending on the place of installations. We have some organizational parts in general, dual detector dependency type A and B, optimize the alarm process and information exchange. We have some maintenance issues and so on. There are a lot of best practices we have identified, and we have write them into chapter 7 of the false alarm study. And Lance will get into the details in his presentation after mine. There are a lot of best practices. Next slide, please. I do not see the next slide.
We're on a slide with conclusions. It looks you have a little delay on the update.
Okay,
of the slides.
okay. I take a look to the conclusions. Okay, what are the conclusions we have done? The control of false alarm is facing several challenges. Okay, raising the awareness for appropriate planning and application. That is the same statement to Michael. Different definitions, detection methods, activation conditions, technical application standards are existing in the different countries. Just to have the same product standards does not say that all systems are the same, because the national applications are very different, as we have seen. Today, the majority of false alarms of FDS are due to deceptive false alarm caused by steam and dust. That are the biggest issues we have to address. Modern high-quality technologies, application rules, and maintenance are able to decrease the number of false alarms, as we have seen. By the way, as we have done our investigations on false alarms, we have seen that in some regions, the fire services said, okay, we have 30% of our false alarms in 5% of the objects. It means that they go out often to the same objects. That is a clear point to address false alarms in the management, the building management, and so on. Okay, there is a whole range of strategies to reduce false alarms further. Of course, we can do more. The industry is continuously working on improvements to reduce false alarms, and the measures are not only technical issues, but we see the first positive actions in the statistics. And we need a holistic approach is required to integrate the activities of system owners and other stakeholders against false alarms. It is a question of the building and site management. Next slide, please. Okay, everything I have told and explained is in the false alarm study in the first edition. Now we have the second edition. It will published in 2022, so sorry, 22, and with some details more, a lot of detailed information on the specific situations in the countries and so on. That is the first point. The second point is we have elaborated this fact sheet, increase fire safety by understanding false alarms. Lance will go into the deep dive on this point. We have at the first issue that we need these terminologies a little bit clearer and subcategories and so on. We are discussing that point in the working groups of this standardization, and this webinar is to discuss with you those activities. Okay, next slide, please. With this, I will say thank you for your attention. And I guess the key message is that false alarms are existing everywhere where you have an exchange of information. In the context of fire detection systems, we have a lot of false alarms, but the most of them comes from deceptive alarms. It means we have a planning and application issue to solve. And the question, is that high or is it not? I will say, of course, every false alarm you can reduce is better, but we have to discuss how many false alarms are acceptance and how many are not. And it is not easy to answer this question. It is better to have a false alarm than to have a real fire condition which you do not have detect. Okay, thank you very much for your attention, and I guess we will have some discussions after the presentations.
Thank you, Sebastian. Thanks for the update, and it's clear a lot of data has been collected. I think it's also a confirmation of what Heikki said before when you talk about EU fire stats, that the difference of definition between the different countries can make it very difficult to make comparisons, because the meters seem not to be equal in same length in one country versus the other country at that time. Then of course the next step is how you can use this data and the data which is collected and analyzed, how you can bring this back in opportunities for improvements. And that's basically a part where Lance Rütimann will guide us through on the strategies to reduce false alarms and the lessons learned. So Lance, I would like to hand over to you.
Thank you very much. So welcome to this part. I have the pleasure of actually tying a lot of what Heikki has said and what Michaël has said and what Sebastian has said, and then to some hand-fast activities or measures. I've had the pleasure of working on this project together with Sebastian since 2013 and organizing some of the, especially the meeting then in Switzerland. And I have to concur that the discussion around false alarms has led to some very remarkable learnings especially that false alarms is an opportunity and not just something bad. So move to the next slide, please. So in the next 20 minutes, 20 minutes, I want to leave two messages behind with you. First off, that including false fire alarms in the initial safety concept and also in the design of the system is an important activity with the beginnings of how that system is going to work in the future, but also we'll see later as a system develops with the life of the building, use of the building. There's another fundamental area, and that has to do with monitoring and reviewing those alarms. And we've maintained that monitoring and reviewing the false as well as the real and managing their causes, that this can provide an overall improvement on the fire safety. So it does not become something of a nuisance. It actually becomes a source of valuable information that will allow a system to provide the service that it's intended to do, and that is to keep lives safe in a building, whether it's people or animals or other life forms. Next slide. Just want to shortly reiterate what my colleagues have already said before about the fire categories. The deceptive activations, that's already been explained. First off, that makes up more than 40% of that. The system detects something that thinks it is a fire and reacts to it, whether it's smoke or heat. The other part is the equipment or technical failures. There can be many causes for that. The piece of equipment is not working properly. It could be that water is running in somewhere that shouldn't be there. And we saw that this is in the range of around 15%. And then the last one is around the malicious and good intent activations. So there's been a human interaction with that. And it's important to remind ourselves of these categories because that's where we can then focus our actions and see where we can get the most out of improving the overall fire safety on the system, but moreover also managing false alarms. Next slide, please. So we're proposing then this holistic approach, and we're looking at 4 pillars in facilitating managing those false fire alarms. There is no one part that resolves everything. We need to take all 4 parts into consideration. The planning of the system, the products, components, and systems that are used in the technical approach, the organizational side of fire safety, and of course the maintenance of the system. And in the next slides, we'll go into each one of these a little different detail. Next slide. Let's take a look at the planning. I found Sebastian's comparison on the false alarms to be quite interesting, that not only fire systems have false alarms, there are others. We can say here exactly the same thing. If I have planned well at the beginning, then I know mostly what my variables are going to be. I know what I'm up against. And the same is here also. I need to understand what are the requirements that are coming from the authorities and from the client. What is their needs that they have? And then also look at the environment in which that system is going to work. Are there any form of negative influences that could lead to false alarms? And I need to address them in one way or another. Either I need to remove them or I need to find a way to be able to manage them. It's really important, as I've mentioned before, to integrate the possibility of false fire alarm events. You can imagine I could reduce any false alarm to the point, or the eventuality of a false alarm, I could reduce it in the system to the point that I have none at all. On the other hand, I increase the risk that maybe a system is not able to detect an event early enough at a time where people can rescue themselves or measures could be taken at the site, intervention measures that could be taken at the site to stop a larger event from happening. I make a comparison here often then with vehicles. We have vehicles that tell us whether we're too close to somebody. It could be an accident, and sometimes it goes off and there's nothing in front. Sometimes it goes off and there is something there. The other part of the planning is I really need to consider what are the products that I'm going to need. And I'm not talking about any specific manufacturer. This is about looking at the typical type of the type of solution that I'm going to have at the end. So what kind of products am I going to be using, and what are their settings that I see in the planning? And it needs to also meet at the end of the day, of course, the site requirements in the situation that I'm going to be up against in this application. Another part that we've seen this very often, choosing the placement of where a device is mounted. How is it that it's going to be able to perform as intended, but without setting off a false activation? An example of this would be mounting a heat detector in a kitchen, and afterwards an oven is installed just under this heat detector. You can imagine that every time the oven is opened, that detector, of course, is going to receive a certain amount of heat. Or installing a smoke detector in an area where welding is done often. So we have conditions that could be interpreted as the initiator of a fire, but in fact are normal parts of the operation within the building, are contained as such. So we need to make sure that our devices are installed on the right place. And we're also calling in for planning to monitor and adjust the system after the commissioning. And this is not just when the system is totally new, but even after changes that are made. We need to see how the system is going to react to the conditions around it. As all of us know, you put a system inside a building, and the moment you bring people in, then you have a number of variables that are not always controllable. So we need to see how the system is going to react and perform in that situation. So these are just some of the planning. Let's go to the next one. If we can switch to the next slide. The products. So I have my idea of where I want to go, what objectives I need to achieve and which ones I want to achieve. And then I need to choose now the products that I'm components and systems that I'm going to put in there. And we do urge the usage of quality components. And how am I going to measure that? So one way of measuring that is requesting from the supplier a proof of certification by a notified body. And I'm sure everybody on the call knows what a notified body is, but just in case, that is an organization that has been designated to assess the conformity before it is placed on the market. And verify the validity of the CE marking. Why is that marking on there? What has been tested? Against what standard has it been tested? And then we're sure to have a situation where we have a product on the market that has met what's considered the acknowledged use of technology. Then each product will have some way of selecting parameters or settings, and they can be defined to optimize their function in that particular site, but also on the location that they're at. And at the commissioning phase, or when it is put into operation, then the technician can check to make sure, are these the proper settings? The last bullet point here, you say, well, what does that have to do with products? Why have we added that into here? It has everything to do with products. I can have the best product in the world, but I haven't installed it properly. I haven't commissioned it properly, and I haven't maintained it. I don't have the knowledge. So it's a call then to make sure that the services that are secured are done from personnel and companies that are qualified to actually do this. So this brings us then to the next slide. We've had the planning part, we've had the products part, now we have the organization. So in any fire safety concept, I will have some structural aspects. We've talked about the technical part, because that's where the false alarms are created, but it requires, of course, an organizational part in behind. And what we do need to do is encourage end users to understand how the system is operated and to make sure that we provide comprehensive instruction for them and for their employees. Of course, a great system, a great fire safety system, is one that nobody notices, but it is working in the background. But when it is needed, then we need to make sure, of course, that the end user and their employees are able to operate it. We've also found that what's important is somebody needs to be named who's responsible, one or two, depending on the size of the location, who's responsible for that fire safety person, the go-to, the one that can tell us as a technician how the system is functioning, how it's operating, where are some of the problems. Not everything can be recorded in the log file of a fire safety system. What you do want to do is also instruct the end user on what are the possibilities or measures that could be taken to reduce false activations. And that does require awareness raising. And again, we have in our fact sheet here a number of examples of what can specifically be done. I think another important part is intensifying the collaboration. We heard in some of the discussions, I remember specifically on our meeting in Göteborg, where the fire department and a local manufacturer had a specific arrangement that the fire department was part of their safety concept because they had a situation that was going to activate alarms from time to time. But I may need to involve those authorities, like, for example, as Michaël has talked about before, to see how I can optimize my system performance, but look at the system performance as something much more holistic. So I consider as part of the organization these external stakeholders if I'm looking at it from the perspective of the building owner. And that can have an impact on the overall intervention processes, whether they're from external or moreover internally. One thing that we do see again from time to time, it gets forgotten. You want to clarify the impact when in-house work is conducted. Somebody is making a change, maybe they're cutting a door open or a piece of metal, and there's a fire detector up above that is going to pick up that and could set it off in an alarm. So we need to make sure that there are processes there that also the end user knows. If I have people in the building that are doing work that could set off the fire safety system, that we have processes in place to either deactivate and reactivate, not forget, and to avoid false activations. And what we would also say that the organization needs to have some way of monitoring and maintaining the performance and looking to see what the constant improvement measures are going to be. And again, there will be more. These are just examples. This brings us then to the last part, and actually the oldest part of the system, because at the beginning, if we could change slides, at the beginning, when we do the planning and when we decide, sorry, one slide back. If we do the planning and we've done the installation and the commissioning, then of course the longest part is the maintenance of the system. We'd like to start off with what I've already mentioned before in the products, but here again to reinforce that. So we have the opportunity since more than 5 years now since the standard was published, the EN 16763, to ask for proof of the necessary skills and expertise and knowledge. Now, most countries, or a number of the countries, will have either the standard or the intent of the standard built already into their national standards. But it gives a building owner, an end user, the opportunity to be able to establish that the persons and the company that is working on my system, that they have the necessary skills and training and expertise and knowledge, and that this is being maintained so that the work that they're doing on the building is also of a minimum quality. Then the inspection and testing of fire detection alarm systems. This is something that I do this work for my own company, looking to see what has happening in the different countries. And we see that some have quarterly, some have every 6 months, some have once a year, some even talk about every 2 years. The testing inspection should be at least once a year, especially in a building where things could change quite often. It is the one thing that would allow the service provider to indicate to the building owner that there's something here that is not meeting the original intent of the fire safety. Of course, there will be changes in time, also with technology, that will allow us to do even more testing in automated ways. But what we cannot forget is that we still need to do that visual inspection of the system to make sure that it's not being affected by things that could lead then also to false alarms. Then consider improvements, modernizing the system, keeping it up to date, having system adjustments made, and certainly regular training of the staff there. That's important. Repairing and replacing components. Don't wait until this leads then to a false alarm. And we would see that we need to have some maintenance of the works that are conducted and the alarms, whether it's a physical or electronic logbook. What's important is this provides a basis for a dialogue between, I mentioned in the slide before, that person who's responsible for the local system and the technician that's there. And then last but not least, and we see this from country to country, it's different. Some are 3, some are 5, some are 10. Some are when the building or a fire compartment is affected in a refurbishment, to have the overall concept looked at every 3 to 5 years by somebody who is competent for that. Some places they need to be licensed, but at least that they are trained for this activity within the jurisdiction that they are working. Come to my last slide. Conclude. What we saw in the studies from the different countries, we saw that the reduction of false fire alarms over the last decades has decreased significantly. When I started in this business over 30 years ago, it was not uncommon to have 1 false alarm per 100 detectors per year. Today, that is much, much lower. Of course, the number of alarm systems that exist have increased as the number of buildings increased. And what we also saw then from the statistic that Sebastian showed is the number of real alarms has stayed, but continually the reduction of false fire alarms is something that we can establish. But we need to continue with the following strategies. Again, the appropriate planning and the application of the right fire detection components and fire system. This is important to be able to manage and reduce those false fire alarms. And as I've tried to outline also, that it provides a basis then for understanding the overall fire safety. Second, need to maintain on a regular basis and have professional servicing done, and build in the monitoring of the performance with regular reviews of the fire safety concept to see if there are areas that need improvement or corrections. And then last but not least, again, managing these false fire alarms means reviewing them and understanding the events. And that gives me the possibility then to decide and define what measures do I have to deploy to be able to avoid that in the future, whether that is a technical measure or whether that is a procedural measure or an information on people, what they're allowed to do and what they're not allowed to do, so they don't negatively affect the overall fire safety. So with that, thank you very much for your attention, and I'll hand back over to you, Paul.
Thanks, Lance, for the update. I think if you look to the presentations given, that gives a nice overview that I don't want to call it a nice overview from false alarms, because that would probably be the wrong remark. Heikki, there's one question which came up on your side. You talked about fire stats, the EU fire stat. Of course, fire statistics have a very wide understanding. Is there a focus area where they focus on? Is that root causes? Is that casualties? Is that, or is it in the whole width of fire safety?
It's pretty much on the whole wild of the of the fire safety. But of course, the focus at the moment is more on the building fires, and even more so on the domestic building fires. So this kind of limits it a bit. One thing that I didn't mention in my presentation is an issue that, as we all know now, that the member states are approaching this issue in a very different manner, and the definitions from one country changed to another one, as we saw also in the definitions for false alarms. It's the same case, and I think in this situation the strategy for harmonization definitely cannot be that you dump something well thought through on different people and then they will just nod their heads and start work accordingly. I think the challenge will be to define kind of a harmonization vision in the future, towards which then the different systems would be developing over time. And I see that probably one good way forward would be to start with something small, looking at indicators that most of the member states are looking at already, and then step by step expand it further.
Okay, thank you. Thanks for that answer. I see a hands up from Martin Harvey. Martin, is that a hands up for a question?
It is certainly a question and a statement, Paul, if that's okay. First of all, Sebastian, well done. You've really captured everything. I think, as you know, I've been working with these false alarms for over 15 years, I guess, and your presentation really has captured all the key elements as far as that's concerned, of which data is obviously one of the biggest headaches that we have. And speaking to Heikki from the EU there, the first thing as far as fire detection and capturing the data, it's nearly always the blue light service that's going to be the ones that can actually capture it. So it's got to be the fire brigades attending incidents, because as an industry, we don't know what's going on in terms of that result. And having a uniform way of capturing that data would certainly help everybody. And as Sebastian pointed out, trying to understand how big the problem is very difficult. And one of the anecdotes that he came up with was a lot of the fire brigades find that they keep going to the same premises. Well, certainly when I was doing my study, we had a hospital in London where the fire brigade attended sort of 2 or 3 times a week. So much so that one of the firemen got so friendly with the nurse, he actually ended up marrying her. So there can be some odd outcomes from these things, but it is one to certainly concentrate on, and one that fire brigades should obviously encourage those end users that have troublesome ones to actually look at their systems there. Just coming on, as some people know, the UK, we did a study about 6 or 7 years ago now. And whilst we've got all of these unwanted fire alarm signals or false alarms, trying to pin down the type of device that is coming is actually causing these is probably the next area of study to actually look at. Are they coming from smoke detectors? Are they coming from heat detectors? If so, which types? And how old are these devices? And one of the most interesting things that we found on ours when we did an in-depth study was the actual manual call points. We had something like, I think it was 15 or 16% of unwanted alarms were coming from the manual break glass call points. So it wasn't, shall we say, the automatic part of the system, it was coming from those. Again, picking up what Lance was saying here, a lot of it was down to design and having the call points in the wrong place. So people banged them with doors. They thought they were the exit buttons for access control systems. And we even had cleaners hitting them with broom handles. So there's still a lot of work to be done. I think the team have done a really great job so far under Sebastian. And with that, I'll let somebody else have a question, if there is a question or a comment on what I've just said.
I think Michael has his hands up. Please go ahead, Michael.
Yeah, I'd like to respond to what Martin said about the manual call points. We found out that manual call points are equally unreliable compared to automatic alarm calls. So we have water, we have damage, we have misunderstandings and stuff like that. So we respond in the same way to manual call points. I think one of a very important insight that we have in the Netherlands, which arrived a few years ago, is that and I don't know how this is regarding other European countries, but if you look at the responsibilities, it is the responsibility of the user to discover a fire and to report it, because it is impossible for the fire service to discover fires because they're not there, you know. And it's the responsibility of the user. So actually, it's absurd to directly connect the automatic alarm to the dispatch center, because you're confusing responsibilities. It's not the responsibility of the fire service to discover an alarm. And if I look into the comparison that Sebastian gave, you see all systems have false alarms. So you can even have a false alarm when trying to detect cancer. The next question is, what is an appropriate response to an alarm? So suppose my GP has a false alarm that I'm actually having cancer. He doesn't call my mom, he doesn't put it in the newspaper. No, he calls me because I'm responsible for my body, right? He doesn't call anybody else. Same thing here for fire detection system. Don't call the fire service because they're not responsible. Deal with it yourself because you have the equipment for it. And as soon as you confirmed it, we're happy to help you.
Michael, this relates to a question which came up in the preparation of this webinar. And the question was if the fire brigade or the alarm responders, just how you want to call them, if they have tools to require additional equipment, additional measures, additional processes from the end user, because it looks like to be very open. There is an electronic alarm, it's dispatched to somewhere, it's transferred to the fire brigade. Are there any tools or things which the fire responders have? Who decides if the fire truck rolls out and or stays inside? Is that in one or in another way organized or defined, or you're on the mute?
Yeah, I understand. You can compare this to a regular 112 free call. A person is present at the location of the incident, and he will speak to another person at the dispatch center. And these two have to handshake. And if the person at the scene has nothing to say, the person at the dispatch center cannot appreciate. So it's a cooperation between these two. And I think the problem with fire installation can detect, but cannot appreciate. So the person at the dispatch center has nobody to cooperate with. That's the biggest problem. So I need some kind of in-between layer. It can be technical, it can be a person, I don't care. Somehow who has the responsibility of confirmation. And I understand from my local norm commission, who makes the norms for fire systems in the Netherlands, that only the detection of one particular fire size is allowed, which means wooden blocks on the cooking plate. And the regular fire system is not even allowed to detect anything else. So it's cannot be used for confirmation. We need something else. We need some additional system. And I feel it's not the task, it's not the job of the fire service to assist people to confirm it. I think there's plenty of...
Can I come in and ask a question there from you guys, obviously in Holland? Because the UK fire service was taking a very similar view, but they've had a number of incidents whereby an unmanned premises, the alarm has gone, say, 4 hours after it was occupied, and they didn't actually go. And there's been some devastating losses. Whereas if the fire brigade had gone, the business interruption and that side of it would have actually changed. And the UK fire service has now gone from being a life safety operation to now business continuity. They're concerned, the concerns here are businesses whereby there's nobody on the premises, the automatic alarm system goes off because there is a fire that's caused by an electrical fault 4 hours after everybody has turned up. So you're saying in the Netherlands at the moment, you wouldn't attend that issue unless somebody confirmed it on site, which there's nobody there. And I don't disagree with you, to have a better confirmation of it would certainly be a way forwards. One of the things we're working on the UK at the moment, I've been working on, is actually with the security industry, is a thing called ECHO, which is where all the alarm signals go through a central national computer system that's looking at verifying things. It's working with security because we have security tend to use a number of alarm devices before the message is sent to the blue light service. We're working at the moment with the fire service to move that along. So what we would do is we send the fire service to say, we have a fire signal from this particular premises. It's on the second floor and we have a current temperature of 105 degrees C and it's risen 40 degrees in the last 2 minutes. That's the sort of information we're going to be sending automatically to the fire service in the UK. Would that be something that you would respond to?
I don't think it's my task as a fire service to follow the temperature in the room. But on the other hand, I think there's plenty of parties in the market who can offer that service. So if you're not there on the premises to confirm the fire, I'm sure you can find many parties like private dispatch companies, private detection. I don't know.
No,
you
can't do that. We've had that and we killed some people doing that. We sent them into a fire and they died. No.
Wait. I don't think we don't understand each other properly. You see, I suppose I'm a factory owner and I'm worried that in the middle of the night when nobody's there, there's going to be a fire and nobody's going to be there to confirm it. I don't expect from the fire service to confirm it because it's not our legal task. I go to a private market and I ask for private parties, can you help me whilst you're on the distance to confirm that there's a fire? And some party will say, of course, I can install cameras, I can install thermo sensors, do all kinds of stuff. I often give a different example. If I have a factory or, for example, a car factory, I don't care. I have a private party. They know when my coffee machine needs refilling. They know when my solar panels need washing. They know when my reception needs vacuuming. They also know when I have a fire and they will call the fire service. So I think that a private company will get a relationship with a private party who can actually understand what's happening on my premises and send me the right help when it's required. So I don't want all that information because it's not my responsibility. I don't want to go into that. And I also think I'm not the right party to offer that service. And there's plenty of innovation in the market who can do much better than me.
Thanks, Michael, for that.
I think I have to disagree with you there from some of the incidents that we've had whereby we've had that situation and people have died. One was a shopping centre whereby they employed a company to investigate the alarm. The guy went in to investigate and he never came out again. And there's been 2 or 3 incidents like that. Asking untrained people to attend potentially large factory and warehouse fires is unacceptable over here.
I'm not sending in people. I'm asking them to monitor detectors. So you gave the example. There's a detector going from 100 degrees to 105 degrees. Send that information to a private party. They will confirm, and then they can send that information to me. Don't send unskilled people into a fire. I totally agree.
We are close to a 4:45, so I would like to give the opportunity to Sebastian as his hand up, and I think Sebastian, there's also a question for you in the chat, which
yes, I would like to pick up the question from the chat, but let me state out that the point is, in my opinion, as Siak Tal has written in the chat, maybe you lost important time. The verification is on the one hand, on the other hand, maybe you will lost time, and you need this time. If I take a look to the response times, which I know in some countries, we are talking about 8-9 minutes as response time for the fire service, and including roundabout 1 or 2 minutes by fire detection, fire alarm systems. If you go now into detail and say, okay, let's make a verification and so on, I'm with Tal to say, okay, maybe you lost important minutes. But let me say something about here from the questions. Here was one question from Dio Cook, for example, of loss of acceptance against technologies. This an example could be if you have a false alarm in your private room at home. The first time you will take a look, okay, what happens, go on to the alarm device and so on. Okay, and then you understand it was a false alarm. You maybe do not understand why, but you have understand, okay, here's no real fire alarm. In the next alarm situation, you maybe say, oh, okay, let's take a look. Is it a real alarm or not? And if you have some of those cases, each case will result a lower acceptance from you against those technologies. And that is the point we have to address. We need a tough reaction and an urgent reaction. And that is the reason why we have to address that point, of course. There's another question from Michael. You have asked, is it high or is it not high? To make a very short and clear message, it is no problem. It is absolutely no problem to produce a fire detector which is able to detect every fire. It's no problem. It's no problem to produce a fire detector who is resistant against false alarms. No problem. The challenge is to produce a fire detection which is able to detect a real fire and also be resistant against false alarms. That is the point. And at the last statement I will give is the answer of the question, is it high or is it not high, the ratios? I have not given you the answer of this question up to now, but now I will give you a little bit answer, not a fundamental answer overall. As I have seen, okay, the ratios 80%, or in your data set, Michael, we have talked about 95% and so on. Is it high or is it not? To answer this question, I have taken a look to all other technologies and so on, which I could find. And as I have seen personal scanners, what do you think? How high is the false alarm ratio? 99.9999% false alarms. If you take a look to the cancer diagnosis, skin cancer, for example, which you have an inspection via your eye, we are talking about 90%. If you take a look to prostate cancer diagnosis with complex instruments and so on, we are talking about round about 70% and so on. As I have seen that, I have understand that we have to answer this question on another level, and the level must be real versus false alarm. And in some investigation, we have seen that the average of the estimated damage by fires, we are talking about, in average, round about, let me say, 50,000 euros in average, between 50,000 and 100,000. If you have in fault alarms, you're talking about 500 euros or maybe 1,000 euros, or in some other countries, maybe 2,000 euros or something like this. So the quality is another one. And I guess for the future, we have to deal with that topic. What is okay, what is not okay, and so on. Okay, thanks for the question.
I would like to give Michael a last time to respond, and then I would like to close off. We are close to the closing hour, and I want to respect that also. So, Michael, please feel free to.
Yeah, I really appreciate the comparison that Sebastian gives to other systems that have false positives. I really appreciate it. And then my question is, if I get a false positive on cancer, do I immediately get the chemotherapy? Do they do another check? If I really have, well, I can give any example. Do I, at 2 o'clock in the morning, ask 6 people to leave their house and jump on a truck? So the question is, what is an appropriate response to that first initiative call? I have another example. Some pilot pushed the hijack button in the cockpit at Schiphol Airport. And immediately, you know, the minister was put in a safe house and all kinds of stuff was happening. And of course, unfortunately, it was a false alarm. An appropriate response to the panic button in the cockpit is send, say, 4 guys with a big gun to check it out. You know, you don't need to put the minister in a safe house. So what is the appropriate response? That is the question. And I think in many cases, the appropriate response is not sending a fire truck, but checking out, following the temperature, and so on.
Thanks, Michael, for that. We are at 4:45, so I would like to close this webinar. I want for sure what my takeaway is that it's good to have the dialogue between the fire and the electronic industry and the alarm responders, and see how going into the future we can, because if you there were a few remarks in the chat also, which always come up in these discussions. What if the fire brigade waits 2 minutes and it's a change between a big fire and a small fire? And then somebody else told me a few weeks ago when we had a discussion, said, what if the fire truck drives somebody on a crossing because they go with full emergency and somebody is killed on the way to a fault alarm? So I think there's a lot of dialogue, but at least for the future, it looks like we have still work to do, and I think it's good to have these kinds of dialogues to understand from different stakeholder sides what their point of view is. I think also what was very nicely highlighted during this webinar is that the collection of data is essential if you want to come to conclusions. It doesn't matter if you talk about false alarms or if you talk about casualties or if you talk. I remember on one of the Fiat meetings, they discussed the definition of death in a fire, and in one country you have to be death in the fire, and another one if you die within 4 days after the fire. And then if you look, yes, then the numbers can be completely different, and then you say, oh, this country or this region is doing very well, but that doesn't balance us out because they measure on a different way. So I think the data collection can help us to analyze it and then also see where we can gain most benefit of the improvements we make, because that's the whole goal. And the confidence in a fire safety system is also essential for how people react on that, but also how the alarm responders react on that. If every alarm would be a hit on, then probably there would be, I would not say there would be no complaint, because other people would complain, but that would be at least for the fire responders a better situation. But I want to thank the presenters and also the attendees, so as well Heikki, Lens, Michaël and Sebastian, also for the preparation and the prep work done. I really appreciate that. In the name of the board of Euralarm and all the Euralarm members, I want to wish not only the presenters but all the participants in this webinar a very good Christmas break, and all the best wishes for 2022. Stay safe. That's, I think, the most important one. And we hope to see you or meet you on one of the events from Euralarm in 2022. Thank you and have a good day.
Thank you very much.
Bye-bye.
Bye-bye.
Thank you. All the best.
Thank you very much. Bye-bye.
Bye-bye.
Thanks. Bye.
Goodbye.
Bye-bye. Bye.
So, Michael or Michael, thank you very much. It is a very constructive discussion between us, and I will be happy if we keep in contact. And yes, let's see what will happen next.
Yes, it is, as I said so, Sebastian, it's nice to meet somebody who you can discuss this topic into depth. I've grown from that kind of discussion. I get a lot of new insight, so I'm grateful for that.
Yes, thank you, Michael, and Merry Christmas.